All right, so yesterday, our learning target was 2, and I'm going to start with yesterday's assignment because it was a long one and we didn't get to finish. We were to understand the relationship between angles, triangles, and polygons so that we can solve real-world math problems that involve these things, and triangles as well. We got to comparing and modeling angles. We described triangles by the number of sides of equal length and by the types of angles they had. And we pretty much stopped there. We did build some quadrilaterals from triangles, different triangles, but we didn't get to talk a lot about polygons. So today we're going to continue with this, but we're going to start with our exit tickets. So let me do that. I picked a few of you that did an amazing job, and I am going to share. Let's see if this is, oh, nope, wrong one. This is what we asked you to do yesterday. The exit ticket for yesterday said, explain the difference between a right angle, an acute angle, and an obtuse angle. Katie, I didn't get yours. Reese, I didn't get yours. Leo, I did not get yours. So I need you to do those exit tickets when I ask you to do them, because then you get a 1 in the grade book, okay, for explaining your thinking. Everybody else, you should see I returned yours to you with a comment. And if you didn't get it returned, you definitely got a comment and you got a 3 on yours. So if you didn't get it returned, you'll see you got a 3. I had 4 students that I wanted to share what they wrote. So I'm going to ask Lila Maris, Finn, Charlie, and Sunny Poe. They're going to share what, nope, don't take it unless it's yours. That's not yours. Well, you got to read for your name. Read your name. All right, so I'm going to have them share. I'm going to get the microphone, and then I'm going to write what I hear them saying. Let me get a white real quick, because these were really good explanations of what the 3 angles are and how they are different. Now, some of you were absent yesterday. When you are absent, you still need to write it in. So you should have a colored pencil. You're going to write your correct answer if you got a 2 in colored pencil. If you were absent, you're going to write in colored pencil the correct answer. Some of you got part of it right, you just didn't use words to explain. All right, here, Lila, go ahead and share, and I want you to stand right here.
Okay.
Go ahead and read what you wrote.
So I wrote on exit ticket 7, a right angle is 90 degrees. A acute angle is 89 degrees or smaller, and obtuse is 99 degrees or above. Then I drew some examples of right angle, and obtuse, and acute. And I wrote the definition, well, like not the definition, but what they were under them.
Okay, so you labeled them. Okay, so here's is what she said. It just means that the acute is smaller than the right, and the obtuse is larger than a right angle. Even if you would have said that, I would have given you credit for it. Okay, so be thinking. And here we go. It's in red. You can write that. If you guys can let them see it, move to the side, that would be great. Okay, thank you, Lila. You can go sit down. Here you go. Charlie's going to read what he wrote. Little different.
Acute angles are smaller than right angles. Right angles is 90 degrees, and an obtuse angle is bigger than right
Okay, so acute angles are smaller than right angles. A right angle is 90 degrees. And an obtuse angle is bigger than a right angle. Okay, what did you write, Sunny?
How do you know the difference between a right angle and a obtuse angle? A right angle is like
Face your audience.
is like two sides of a square, and a acute angle is a little bit smaller than a right angle, and a obtuse angle is bigger than a right angle.
Excellent. And Finn, last but not least.
Right angles are 90 degrees, and acute is a smaller degree. And obtuse is wider than a right angle.
Okay, so I hope that helped. Let's see. Can we make those angles? Go ahead and make sure you fix it if you got a 2. And then let's see if we can make those with our hands. All right, I'm going to stop sharing because I want to show you and I want you to make a right angle. And I want to see you make a right angle with your hands. A right angle is like a square corner. You might have said that too. Henry, can I see your square corner or your right angle? Reese, let's see yours. Leo, Haley, Calendar, can I see yours? Gavin, everybody, Robert, 90 degree. This is a right angle. Let's see it. Okay, now make it acute. It's smaller. It's cute. Acute. Katie, let's see it. I don't see your hands, Katie. Acute. Yeah, some of you did it with your scissors. Haley, Calendar, I don't see yours. Okay, right angle. Now obtuse, bigger. Obtuse, obtuse, obtuse. Don't use the scissors for it. I want your hands. Thank you. Right angle. Acute. Come on, Henry. Let's see it with your hands. Right angle with your hands. Henry, hands. Come on. Thank you. Obtuse. You need to use your hands, Henry, so that you can make an obtuse. Thank you. Put your wrists together. 90 degree. Right angle. Acute. Right angle. Obtuse. Right. Obtuse. Acute. 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 Right angle. All right. Shake it out. Shake, shake, shake. So that's your review. Hopefully it makes sense now. We'll keep talking about it. And then we will talk about it through this whole unit. We also had a lot of new vocabulary I wanted to just make sure we review because it's a lot. Angles, they're a figure formed by 2 rays or 2 line segments that meet at an endpoint. Remember, a ray is actually like 2 arrows that meet together in a corner. A line segment has the 2 endpoints. A right angle, we said, measures 90 degrees. And an acute angle is less than 90. Obtuse is greater than, but not greater than a line, which is 180. All right. This is the vocabulary we didn't get to yesterday. So everybody should be listening. Polygon is a closed plane figure. How many of you saw this on Think Central today besides Charlie and Lila Maris? A couple of people. If you got on to your Think Central, we didn't finish lesson 6.1, so some of those were going to be tough. Here's some of that vocabulary that you would have read in your Think Central assignment. Polygons are just closed figures. They made up of line segments, not curved lines, but straight line segments. But they can't have an opening. We're going to learn more about them. Here are some examples of polygons. An octagon. Give me a thumbs up if you've heard that word before. Octagon. Like octopus, right? 8 sides. It's a polygon with 8 sides. Hexagon. Hexa means 6, 6-sided polygon. Penta, like a house. 5-sided polygon, deca, meaning 10, a polygon with 10 sides. And then this was also on your Think Central. Concave is a polygon that pushes in like a cave. You'll see what I mean today. And convex means it pushes out. It's a polygon that like pushes out. You'll see soon. All right, so we already talked about the angle song. We're gonna move on. We made our angles. We talked about quadrilaterals yesterday. And then we built our triangles. This is where we left off. So we are gonna learn more about polygons today.
That face that is usually covered by her phone has finally made an appearance.
Yep.
Numberup.com's complete digital library of math videos is now available ad-free and child-safe. Tri is a prefix that means 3. Triangles have 3 sides like a sail on the sea. Quad, a prefix that means 4. Quadrilaterals have 4 sides like a door. Pentagon is a prefix that means 5. Pentagons have 5 sides like a school's own walk sign. Hexa, a prefix that means 6. Hexagons have 6 sides like a bolt we twist. Tri means 3 and quad means 4.
What shape is this?
Triangle.
What shape is this?
Quadrilateral.
Which is a rectangle is a quadrilateral.
Pentagon.
What shape is this?
Hexagon.
What shape is this?
Heptagon.
What shape is this?
Octagon.
What shape is this?
This is getting to be a pattern.
Nonagon.
What shape is this?
Decagon. Two last things before we go. A polygon has to have straight sides, you know, and a polygon has to be a close shape. The vertices and sides can't have it in grid. So is this a polygon? No. But is this a polygon?
Yes, because it's straight. You can't tell because of the.
Numberup.com for exclusive content.
All right. All right, kiddos. so we're gonna look at page 302. I think that this is gonna be pretty simple. I'm going to do maybe one or two with you, and I'm gonna let you do the rest because it's not gonna be very tough. And let's see if I can move that. Yeah. All right. So here's on page 302, you're gonna notice that we have a bunch of pictures of polygons. They're all closed shapes with straight lines. So you can have your attention. Hold on. Thanks, buddy. All right. So here at the top, we have the names of the polygons and the number of sides. So a simple one, you guys probably know Sawyer from kindergarten. You probably remember this, or preschool. 3 sides, you've got a triangle, right? 4 sides, this is kind of a new word for us, quadrilateral. Quad means 4. We talked about riding quads yesterday. So that's where that comes from. This is like a prefix almost. It's not, but it's kind of like that, where it has meaning. Octagon is 8, octa, deca is 10, penta is 5, and hexa is 6. Use this up here to name your figures. You should spell correctly because you're looking at the spelling, right? Don't do inventive spelling in 3rd grade. You guys are ready to move on from that, unless you don't have a resource. Now, look at this figure. Let's do this one together. I'm going to first count the line segments. 1, 2, 3, 4, 5, 6. I see it has 6 sides. It also has 1, 2, 3, 4, 5, 6 angles. It is a hexagon. So we're going to write hexagon. The next one's pretty simple. 1 line segment, 2 line segments, 3. 1 angle, 2 angles, 3. All acute angles, by the way, because they were kind of cute and small. 3, I come up here, 3 is a triangle. All right, what do you think number 30 is going to be? How about Josh Lewis? Let's count. 1, 2, 3, 4, 5. What has 5 sides? What do you think? Penta, pentagon. Hexagon has 6, so we count 5. Let's count the angles too. 1, 2, 3, 4. How many angles? So do you think like a house? I always think they look kind of like a house. This one's a little slanted. And these angles, look, we have an obtuse. This one looks acute. We got a variety of angles here. And he said what? Pentagon? Pentagon? That's how you're going to do it. You're going to count. You're going to look up here to try to find out which one it is. All right, go for it. Do your counting. Notice that they have the same number of angles as they do line segments. That's an interesting. Count your sides and check up to the top. Fast. Awesome. You will notice that there are shapes up here that have other names. But if it's a 4-sided figure, even if it's a rectangle, square, parallelogram, trapezoid, we're going to call it a quadrilateral today. We'll explore those next. All the different types of quadrilaterals. Okay, Haley. Thank you. If you are finished with the page, in the margin, try drawing your own. Some of you are finished, you got done real quick. Draw your own octagon, draw your own pentagon, draw your own hexagon if you're finished. It doesn't have to look just like that, but it has to have straight sides and it has to be closed. Right on the margin, I'm just saying for people who are waiting. Are you done? You're not done. I'm not talking to you then. I'm just talking to like Cooper, a couple kids are done. So like you could try drawing a pentagon. 1, 2, 3, 4, 5. It doesn't look exactly like that, but it's still a pentagon. Do you not have a video pencil? Okay, I'm gonna get it. Here you go. Okay, we're gonna go ahead and check these out. Let's see how we did. Haley Booker, what'd you get for number 31?
It doesn't tell you which one's for 7.
It doesn't. That must mean there isn't one for 7 on your.
Yeah, it's right below the triangle.
No, I think you might want to count again. All right, Haley Booker, 1, 2, 3, 4. What did you guys get?
Oh,
What did you get though for your quadrilateral? Because it has 4 sides. All right, let's count for 32. 1, 2, 3, 4, 5, 6, 7, 8. Finn, what should it be?
it should be octagon.
Octagon. And then number 33, Ellie. Hexagon. Okay, number 34. Pentagon. Sorry, I got to write above because it won't let me write below. Cooper, number 35. Decagon. You should have counted 10 sides. And 36. Lucas?
Octagon.
Is it an octagon? I can't even count. I'm going to just have to trust you.
And
Octagon. Okay. How did you do? Fist to 5 on that. 5 means you got most of them right. Fist meaning, Surnay, raise your hand real high.
all of them right.
She's right here with the ponytail. Yep, thank you. All right. If you got a fist, you did not quite get it. So remember, all of these shapes are called polygons. Now, real quick, I have up in my room a poster of shapes. Are all of these posters polygons? All these posters, are all these shapes on the poster polygons? So kids at home, I'm asking if these shapes on my wall are all polygons, but there happens to be a circle and an oval. I'm drawing it for you. So the reason they are not all polygons is why. And it should have looked there, that's better. I have a little curve in my board. Madison, why are these not polygons?
Because there's no like points or anything.
No end points, I like that. They don't have corners. What else? Go ahead. Okay, did you want to add on?
So they're not polygons because they don't have straight sides and they don't have sides.
They don't have sides or angles, line segments, so they are not polygons. Very good. Okay, let's keep going. Not right now. Just give a minute. Can you finish what's in there first? Yeah, finish what you got in there. All right, next thing on our list. Not yet, after this, because we're gonna learn a new concept. This is what some of you were frustrated with today. You're like, what? Mrs. Oven didn't teach me what convex and concave mean? Ah, what does that mean? It is not as complicated as you think.
To learn how to identify convex and concave polygons. Get started. So, convex polygons. Convex polygons are polygons in which all the sides are pushed outward. So let's take a look at this hexagon here. So if you notice, you can see all the sides are pushed outward. No one is being pushed inward or toward the interior of the shape. They're all pushed toward the exterior of the shape. So if you look at the square, same thing. All the sides have been pushed outward. Triangle, same thing. All the sides have been pushed outward. And then we have finally a pentagon, and all the sides are pushed outward. So convex, a polygon in which all the sides are pushed outward. The second piece to this is our concave polygons. They're also known as non-convex. So you might see them in textbooks or in other things we do in class. They're interchangeable. They're concave polygons and non-convex polygons, so both talking about the same thing. And so, non-convex or concave polygon is a polygon in which at least two sides are pushed in. So let's take a look at this. See how this side is pushed in? So it's pushed into the interior of the shape. So this would be an example of a concave or non-convex polygon. Here we have another one. See how it's been pushed in to the shape. It's been pushed into the interior of the shape. Here we have one last one. It's been pushed into the shape. Okay, a good way to remember this is think about if you build a snow dome or if you build a snow fort and the roof caves in. Do you see how if your roof is up here and it caves in? Okay.
Or like you're going into a bear cave, right?
Going
into a cave.
Let's do a quick review. We
Concave.
have two really important words today. We have convex polygons. We have a convex polygon is a polygon.
Okay, good. So that should get you through for a few minutes, right? I don't want you to miss this.
Okay, so
All right, so we're gonna stop that because that gives you the idea. Who can tell me the difference between convex and concave? Madison.
So the convex doesn't go in, and the concave goes in.
Goes in like you're going into a cave. That's the best way I can help you describe it. All right, this is what we're gonna look at. And I didn't put the page on there. Shame on me. It should be your next page. Let me double check the number. Nope, it's not. Okay, go to, it is page 301. Page 301. It is the page before, page 301. I'll write it on there for you. So here's what we have. We have two different concepts on this page. One is about polygons, and one is about concave or convex. So let's remember that a polygon is a flat closed figure made up of line segments, that's what Lila was saying, that do not cross each other. They do not intersect or cross. So you are going to circle the figures that are polygons. Leave the ones that are not polygons blank. Okay, on page 301, you're going to circle the figures that are polygons. Okay, you've got 8 of them. Go ahead and do numbers 16 through 23, and then we'll talk about those and move on to the concave and convex. You can circle the shapes that are polygons. Go ahead. You're doing numbers 16 through 23. On page 301. Go back to the definition if you're not sure. Is this a polygon? Right here. It's a flat closed figure made up of line segments that do not cross each other. Is that a polygon? A circle.
Page 301.
You're on 301. So do you think this is a polygon? Then circle it and move on to the next one. Is that a polygon? Then don't circle it. Is that a polygon? It has to be flat, closed. Why not? Why do you think it's closed? It's still a polygon. Oh my God. Why is that not a polygon? Oh, read the definition. Look at the definition again. Remember?
How many sides?
All right, let's see how we did. Number 16, stand up if you thought it was a polygon. If you are standing up, you were right. It is a flat closed figure made up of line segments that do not cross. Okay, stand up if you think number 17 is a polygon. Stand up if you think this is a polygon. It is not. Here's why. It should not have been circled. It has lines that cross. See how they cross? They can't have lines that intersect. So that is not a polygon. Stand up if you think number 18 is a polygon. Charlie, you don't think so? Sunny doesn't think so? A lot of people get confused on this. Just because it is concave does not mean it's not a polygon. Listen to the definition, Sunny and Charlie. It is flat. Is it closed? It's not, doesn't have an opening. Does it have lines that cross each other? It is a polygon. If you were standing, you were right. You should have circled that. Yes, it does go in, but that's okay. It just means it's concave. It's a polygon that is concave. It has all straight lines. There's no curved lines, so it's a polygon. All right, stand up if you think number 19 is a polygon. Everybody should be standing. It follows the definition. What about number 20? Stand up if you think number 20 is a polygon. Okay, let's look at that. Certainly, why would that be a polygon? Why do you think that? Well, they're all flat, but why is this not a polygon? What does it have that it shouldn't have to be a polygon? It needs to be made up of line what? Line segments, straight lines. Does it have curvy lines? No, polygons don't have curvy lines. It cannot be a polygon if it has a curve in it. All right, number 21, stand up if you think this one is a polygon. Hey, you are right. Stand up if you think number 22 is a polygon. Gabe, why is this not a polygon? It's not closed, right? It would need a bottom line to be a polygon. And number 23, stand up if you think it's a polygon. Max, why is this not a polygon?
Because it doesn't have any corners and it only has 2 lines.
It's just 2 parallel lines. They're not closed to form a figure. All right, now we're going to look at concave and convex. Remember, concave shapes go in, convex go out. If it has a section that pushes in, it's going to be concave. If it's going to push out, it's going to be convex. let's go ahead and let's look at number 24. Concave or convex? What do you think, August? Does it go in or push out?
Push out.
It pushes out, so it's convex. What about 25? Who'd be willing to answer that? How about Paxton? What do you notice about number 25? It has a little cave, doesn't it? So we're going to call that concave. Go ahead and do the last two. See if you can figure out if they're convex or concave. Write them down. Awesome.
I'm done.
Good job. Good job. Okay, so that would be a text, right? The spelling is there for you, so make sure you refer to it. All right, Robert, it looks like you're ready. What do you think about number 26, Robert?
It's a concave because if that cave right there wasn't there and there was a straight line connecting to the other, it would be a convex.
Because it goes in, it's concave. All right, Evie, what about number 27? Oh, I'm sorry. Finn, what do you think? Concave or convex?
Wait, which one?
Number 27?
Oh, convex.
Why do you think convex?
Because
It actually pushes out on all spots. Nicely done. All right, let's see what we're at now. So we should have a better understanding of those vocabulary terms. We are now going to build some polygons from triangles. You'll need your scissors and page 300, let's see, 303A. The only triangles I want you to cut out right now are the top triangles that say A on them. If you want to rip out the page, you can rip out the page. Only cut out these triangles. You should have 6 of them. That's okay. Don't worry about it.
yeah, that's what I did too. Go back one.
It's all good. Okay, we're on 303A. Just cut out the first. Yes, sir. You want me to rip it? Can I help you? We're not going to cut them all out. Just cut out A. See how I circled them, Henrik? Just cut out A.
I meant to cut out all the A's.
All the A's, yes. Cut out all the A's. Yes, I should do it too. I don't understand. Yeah, I'm clarifying. Okay, Gavin, do you have your triangles ready? Okay, here's what I want you guys to do. I want you to take your triangles, use all of them, and see what type of polygon you can create. There's only one answer here. Has to be, I think, one, we'll see, maybe you guys will prove me wrong. Has to be a flat, closed figure, all straight lines, because it's a polygon. And I want you to use all the triangles, and they should not overlap. Do not overlap them. Okay, that's your challenge. I'm gonna put them under the document camera and give you just an idea of what I mean. You should have 6 of these triangles. Well, if you have to use them all. Yes, you could make different polygons using less, but if you use all 6, we should all come up with the same shape. Oh, you're right. I've already been proved wrong. Lennox has proved me wrong. We can make more.
I proved you wrong. I just need to make
Okay. So I'm already seeing some really cool shapes. Really cool polygons. Lennox has an awesome one. All right. Here's what you're doing. You're trying to put them together to form one. I'm going to show you what Lennox did. So because it's harder for him to bring all of his up here. He put 2 together like this. 1 here, right? 1 here. 1 here and 1 here. Is it closed? But this one I gotta cut off the edge. Let's see what kind of polygon it is. It's closed. It has all straight edges. Oh, is it convex or concave? Concave. How many sides do you have, Lennox? 6. So what kind of polygon is it? 6-sided shape is a hexagon. All right.
This is what I made.
Serne, do you want to bring yours up? Would it be easier? I don't know how else to do it because we can't touch.
That's what I did.
Oh, wow. There's some awesome ones. Let's see. This is the one I was thinking we'd all make, but you guys are way more creative.
I know one more.
Yeah, we'll move it up. Yeah, move it up. Up. You will. I'll move it.
I lost one more. I'm gonna go check on my desk. And then
Here, just use this one. Use that one. All right. How many of you made this shape?
I know one more.
What shape is that, Serne?
It's
Count your sides. 1, 2, 3, 4, 5, 6. Another hexagon. Why do you think we're making all hexagons? Why would we be making all hexagons? Josh?
because we only have 6 of these.
Because we have 6 triangles. What do you notice about all 6 triangles? Sunny?
They're all
Well, they're all triangles, but what else? Yes.
They have 3 sides and we have 6 of them. So
Are they different or are they the same? They're all the same. They have the same sides. So yes, we're gonna have hexagons. Do you want to do one more? Okay. Do you have another one, Lennox? Lennox is an awesome one. Boy, Lennox, you're a visual learner. I can tell who my visual learners are, the kids who are having a blast making these.
this is one of mine.
There are a lot of different ones you guys are making, but they're all going to be counted as hexagons. Now, this will not work because they have to share a side. It has to be, you could do like this. That would work.
Like that?
Yep.
It's 7 sides.
No, 1, 2, 3, 4, 5, 6. Still 6. Is it concave or convex? Concave. All right, Lennox, because yours is really cool. Let's try it again. Bring yours up.
I only have 4.
Let's see. So let's see if it's not a hexagon. He thinks maybe he might have made something else. Discovery learning. Let's see. You will. Got to have that patience thing. Oh, is he making a
He's making like one of those sticks.
parallelogram?
I did that.
How many? Is it a quadrilateral?
It looks like it only has 4.
It has 4. He made a quadrilateral using 6. Oh, awesome. That was convex, right? There was no concave to it. I'm going to put that back. I'm going to put this one back up. I have a question for you. What fraction is one of the triangles in this polygon? What's the fraction of one of them? What do you think, Cernay? If I wanted to know the fraction of this, think of it was like a type of food. I have one what out of it? 1/6. Very good. This is 1/6 of the whole. 1/6. So each piece is 1/6 of the whole. 6 6 in one whole. All right. Go ahead and let's cut out your B triangles. These. We're just going to cut out our B's right now. B. Hi. Oh, I'm so glad you're liking it. How are you going to put those together to make a polygon? Remember, the polygon has to be closed, straight sides, no curvy sides, and you can't overlap. We made lots of hexagons. We made a quadrilateral. Cooper, come on down. Cooper's ready. You guys keep trying. Oh, look at his. What do you call that? You got to count your sides to know what to call it. 1, 2, 3, 4. What do we call a 4-sided polygon? Quadrilateral. All right. See if you can make a different one. Ellie, bring yours up. Ooh, look at that one. Oh, that's not a quadrilateral. What is it?
Pentagon.
It's a pentagon. Count the sides. 1, 2, 3, 4, 5. Awesome. Nice. All right, come on, Marin. Got a lot of visual learners here.
I have 2 different ones.
Oh, I think that's the one she did. Pentagon. You want to move it up? Or else it's just a different pentagon. Count those sides. 1, 2, 3, 4, 5. Nicely done. Bird, you want to do one? Does anyone have a different one? Yeah, a lot of different ones still. I think we're doing the same one again and again, you guys. That's also the pentagon. Nicely done. Something different. All right, Sunny, something different. So no one can see, so let's go up here. Oh boy, that's interesting. We have to count those sides to know what it is. What is it? Right, so 1, 2, 3, 4, 5, 6. What is six-sided shape? What is it called? Hexagon. Awesome sauce. Paxton. Put it right up here where they can see. There you go. They can't see that, just so you know, it has to go up here. Whoa, very interesting. Did you count the sides?
1, 2, 3, 4, 5.
6, right? 1, 2, 3, 4, 5, 6. Is it hexagon, and then is it concave or convex? Concave. Okay, we could do this all day, but I have another activity, so you can put those to the side. I'm gonna give everybody a shape. I'm gonna give here are my remote learners. This is your shape, okay? I'm gonna be asking questions about your shape. So remote learners, this is your shape. The rest of you are gonna get another shape. Who did not get one? Does anyone need a shape? No. All right. All right, so this is kind of a listening activity. You're gonna have to really listen. We're gonna do a review of our vocabulary using these shapes. Look at your shape. When I say a descriptor, if your shape is that, you will stand up. If it is not, you will not. If you have a polygon, stand up. Hold your shape up so I can see it. So the only people who should not be standing up are people with curved lines or openings, right? Because polygons are closed figures with straight lines. They can be concave or convex.
I think most of the ones I passed out were.
All the ones I passed out were polygons.
All the ones I passed out were.
Every single person should be standing up. Yours is closed, right? There's no curved lines. Why wouldn't that be a polygon? The only reason, Robert, it wouldn't be a polygon is if it has a curve, like a circle. Does anyone have a circle? Does anyone have an oval? No. Does anybody have one with an opening? No. Yours is open. Yours is not open. No. Then everyone should have stood for polygon. So everybody say polygon with me.
Polygon.
Okay, your next one. Stand up if your shape is concave. That means it goes in, it's pushed in. It has something that pushes in. Yes, Robert? Everybody at home should be what? Look do you see where it's concave? It goes in right here. All right, I see you, Cooper. Yes, yes. All right, stand up if yours is convex. You shouldn't be standing if you're at home. You should be sitting. Right, Gavin? You do not have a convex polygon.
He was standing for the other one, I think.
I know, I'm just reminding him to sit down. All right, looks good. Everyone else looks good. All right, sit down. Here's your next one. Stand up if you have a quadrilateral. Quadrilateral. Haley Booker, are you going to stand up? Yes or no? Why not, Haley?
Because it doesn't have 4 sides.
How many sides does yours have?
5.
5. So did you just hear that? This is important for your exit ticket today. A quadrilateral must have 4 sides. So if you are standing, count your sides and make sure you have 4. If yours does not have 4, you should not be standing. All right, sit down. If you have a pentagon, stand up. All right, Lennox, why are you standing? How many sides does yours have? 5. So we know a 5-sided figure is a pentagon. All right, stand up if you have a hexagon. Ellie standing, Cooper standing. How many sides, Charlie? How many sides do you guys have? You should have 6. Is that true? Count your sides. Is that a hexagon or pentagon? Count your sides. You counted? All right, if you have an octagon, stand up. Anybody have 8 sides? You guys okay? Can you just stand up and sit down? Don't do that, okay? Octagons. Anybody with an octagon? Hexagon instead? Okay. No octagons. How many sides should the shape have if it's an octagon? 8. Any nonagons? Decagons? All right, stand up if you have how did that happen? That's weird.
Ah! What just happened?
All right, 3rd graders, mathematicians, listen up. If your shape has a right angle, stand up. A right angle. That means 90 degrees, a square corner. If your shape has a right angle, all of you at home should be standing. You guys have 2 right angles, right? You have 4 right angles. Stand up. If you have a square or rectangle, you have a right angle, right? All right. Okay, sit down. If your shape has an acute angle, smaller. Jensen, do you think you're standing up? Yes or no? Unmute. Acute is smaller than 90 degrees. Jensen, are you standing up? Can you unmute? What happened to Jensen?
I am standing.
Why should you be standing, Jensen?
Wait. I keep forgetting the question.
Okay, it says the question was
You should be standing.
acute angles. Does your shape have acute angles?
Yes.
How many?
2.
Very good. All right. Stand up if your shape has an obtuse angle. Greater than 90 degrees. Obtuse. Nice. Lots of hexagons out there. All right, kiddos. Nicely done. We are going to go back to, all right, now I have to get into, actually, I am thinking, we will wait on that for tomorrow. So let's go back to our learning target. And I know I've got ink on there, sorry. How are we feeling about our success criteria? How do you feel about angles? Give me a thumbs up, thumb in the middle, or thumb down. Just about angles, right angles, obtuse angles, acute angles. How are we feeling? All right, what about describing triangles by the number of sides of equal length and by the types of angles? Right angles. Okay, what about building these polygons today? How did you feel about polygons? Any better than before? How about convex and concave? Okay, all right, guys, nice job today. We will finish, you can finish 6.1 now and feel confident that you know the vocabulary. We'll start with more polygons tomorrow. You may recycle your scraps and get your scissors and your supplies, and we will see you mañana. Nope.
See you mañana. Bye. Bye. See you mañana.